in today's class. So in our last class we discussed about gas laws, right? So here we discussed Boyle's law, Charles law, right? Charles law for what? Pressure. Charles law for what? Value we discussed, right? Now today's class we are going to discuss ideal gas equation. Ideal gas equation, right? Ideal gas equation. Yes, this one there. So here, ideal gas equation. Ideal gas equation. Right? Here, at high temperature and low pressure, at high temperature and low pressure, right? All real gases, all real gases, all real gases behave like ideal gas. Behaves like ideal gas, right? In an ideal gas, there is no intermolecular force. There is no intermolecular force. An ideal gas obeys below law. See here, whatever the temperature is high, if an real gas, whatever the gas is there, that gas is which type of gas? Real gas, and that gas is having low pressure. That gas is having what? Low pressure. Temperature is high, but what? Pressure is low. So all real gases behaves like ideal gas. So ideal ಆಗಿರುತ್ತೆ. Common ಆಗಿರುತ್ತೆ ideal, right? So behaves like ideal gas. So in an ideal gas, right, there is no intermolecular force. So ಅಲ್ಲಿ ಏನಿರುವುದಿಲ್ಲ? Intermolecular force ಇರುವುದಿಲ್ಲ. If whatever the molecules are there inside the gas, inside the real gas, so there what happens? There is no force of intermolecular. There is no force of what? Intermolecular, right? So here an ideal gas obeys the below law, that is PV is equal to what? NRT. PV is equal to what? NRT. So PV is equal to nRT is called as ideal gas equation. Ideal gas equation. Right? Here in this equation, P is pressure of the gas. P is what? Pressure of the gas. So then V is volume of gas. V is volume of gas, right? R is, so we write R in last, right? Here T is temperature of gas. T is temperature of gas. So then N is number of moles in gas. Number of moles in gas. So here see R is universal gas constant. Universal gas constant, right? So that universal gas constant is have a value that is 8.31 joules per mole per Kelvin. So this is what the SI unit of what this R is a universal gas constant. R is equal to what? Universal gas constant, right? So this is very important. Here PV is equal to nRT is called as or known as what here? Ideal gas equation. Ideal gas equation. So this is ideal gas equation. So ಇಲ್ಲಿ ಏನು ಇಂಪಾರ್ಟೆಂಟ್ ರೀ ಅಂತಂದ್ರೆ ನಮಗೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೇಳಬಹುದು. ಏನು ಕೇಳಬಹುದು? ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೇಳಬಹುದು. At high temperature and low temperature, all the real gases behaves like ideal gas, right? So in main thing was in this ideal gas equation there is no intermolecular forces. There is no intermolecular force, right? So here PV is equal to nRT. PV is equal to nRT is very important, right? So here N is number of moles of in a gas. N is number of moles of in a gas, and R is universal gas constant. R is what here? Universal gas constant, right? So this equation only is the called as ideal gas equation. Ideal gas equation. Got to know. This is ideal gas. Very important. Very important. Example. Right. So next, there is some expansions are there. Expansions. So thermal expansion, linear expansion, volume expansion. Right. Now we are going to discuss one by one. Right. Here, thermal expansion of solids. Thermal expansion of solids. So here, see, thermal means what? Heat. So expansion means what? The body is increasing in its size. The body is increasing in its size, right? See, here when we are going to give the heat, so then in that body, the temperature is increasing. Here in this case, what happens? The different states of bodies, or the different types of bodies, right? Whenever we are going to increase the heat or giving the heat, so the size of temperature is also what happens? Increases. So that type of expansion is called as what? Heat expansion. ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರೀತೀವಿ? Heat expansion ಅಂತ ಕರೀತೀವಿ, right? ಇದು ಗೊತ್ತಿರಬೇಕು. ಅಥವಾ ನಾವೇನಂತ ಕರೀತೀವಿ? Thermal expansion ಅಂತ ಕರೀತೀವಿ. Right? So here in this thermal expansion of solids are in three types. ನೋಡಿದ್ವಿ thermal expansion ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಾಯ್ತು ರೈಟ್ ರೀ. ಇನ್ನ thermal expansion ಒಳಗೆ ಎಷ್ಟು ಟೈಪ್ ರೀ? 3 ಟೈಪ್, ರೈಟ್. ಫಸ್ಟ್ ಒನ್ linear expansion. ಥರ್ಮಲ್ ಹೀಟ್ ಹೆಚ್ಚಿಗೆ ಹಾಕೊಂಡು ಹೋದ್ರೆ ಬಾಡಿದ ಸೈಜ್ ಒಳಗೆ ಏನು ಇನ್ಕ್ರೀಸ್ ಆಗೋದು ಹೋಗ್ತೈತಿ? ಟೆಂಪರೇಚರ್, ರೈಟ್. ಸೆಕೆಂಡ್ ಒನ್ ಏರಿಯಾ ಎಕ್ಸ್ಪಾನ್ಷನ್. ಥರ್ಡ್ ಒನ್ volume expansion. Right? So here thermal expansions of solids are linear, are in three types. One is linear expansion, another one is area expansion, and third one is what? Volume expansion. Now we are going to discuss one. First one. Here, if there is increase in the length of the body, if there is increase in the length of the body on having heating, then the expansion is called what? Linear expansion. Right? See, suppose this is the body, right? If we are going to heat to this body, so suppose this is the original length and this is original length L, right? If there is increasing in the length, suppose the body when we are going to heat, delta L is what? Increased by its original length. So then the body on having heating, right? So then whatever the expansion is happened here, whatever the expansion is happened here, that expansion is called linear expansion. Linear expansion. Nodri, linear agire expansion agire. So anta expansion na enanta karitini linear expansion anta karitini. Right? So if there is an increase in the length of the body, right, on having heating, so then the expansion is called linear expansion. Linear expansion. Both together, very important, right? So here let capital L be the length of the rod. Let L be the length of the rod. L be the what? Length of the rod which expands L plus delta L, which expands del plus delta L when temperature increases from T plus delta T plus delta T. So then the increase in length, is directly proportional to its original length. Second one, change in temperature. Change in temperature. See, one thing here very important. If we are going to consider a rod here, right? Its original length is what? L here, and its temperature at the length, how much it is? Temperature T is there, right? If now we are going to give the heat or give the temperature, let L be the length of the rod, what? So which expands L plus delta L. See, if it expands, right, del L, so then its total length becomes L plus del L. ಹೌದಾ? L ಇದ್ದು delta L ಆಯ್ತು ಅಂದ್ರೆ ಇಷ್ಟು ಹಿಟ್ಟು ಅಂದ್ರೆ ಇದು total length ಎಷ್ಟು ಆಯ್ತು? L plus delta L. Getting my point? So after that one, see, when temperature increases from T plus delta T, so here it is having at original length state, it is having temperature T. After that one, if we are going to get in the heat, T will becomes T plus del T. T plus del T. So automatically what happens here, when whatever the increase in length is there, that is directly proportional to. Nodri, ಈಗ increase in length ಆಯ್ತು, ರೈಟಾ? increase in length ಅದು ಎದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಐತೆ, ರೈಟಾ? ಫಸ್ಟ್ T ಎದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಐತೆ ಅಂತಂದ್ರೆ ಒರಿಜಿನಲ್ ಲೆಂತ್ ಗೆ ಪ್ರಪೋರ್ಷನಲ್ ಐತೆ. ಒರಿಜಿನಲ್ ಲೆಂತ್ ಇದ್ದಾಗ ನಮಗೆ ಏನು ಸಿಕ್ತು? ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಆಯ್ತು. ಒರಿಜಿನಲ್ ಲೆಂತ್ ಇದ್ದಾಗ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಆಯ್ತು, ರೈಟ್? ಒರಿಜಿನಲ್ ಲೆಂತ್ ಚೇಂಜ್ ಆಗಬೇಕಾದ್ರೆ, ಹೆಚ್ಚಾಗಬೇಕಾದ್ರೆ ಏನು ರೀಸನ್ ಆಯ್ತು? ಚೇಂಜ್ ಇನ್ ಟೆಂಪರೇಚರ್. change in temperature, and again directly proportional to what? Change in temperature. Change in temperature. Very important. So here whatever the increase in length is directly proportional to what? Its original length and change in temperature. Change in temperature. Very important, right? So now I am going to write here. See, when the temperature increases from the increase in length, whatever the increase in length, delta L is directly proportional to its original length and what? Delta T. According to my equation, according to our statement, the increase in length is how much? Del L is directly proportional to original length. What is our original length? L, right? So then change in temperature. Clear my point? So now I am going to write del L is equal to, ಇದನ್ನ ಏನು ಮಾಡ್ತೀನಿ? ರಿಮೂವ್ ಮಾಡಿ alpha L right? So then alpha is equal to del L divided by L del T. Del L divided by L del T. Right? Here this alpha is called as coefficient of linear expansion. Right? So alpha na ಏನು ಹೇಳ್ತೀನಿ? linear expansion ಅಂತ ಹೇಳ್ತೀನಿ. ಗೊತ್ತಿದೆ. And this now ಏನು ಮಾಡಿದ್ವಿ? We remove this what? Directly proportional. When we are going to remove what we take here, there is a constant. That constant is called as alpha. That alpha is known as what? Or called as what? Coefficient of linear expansion. So then, what is coefficient of linear expansion? Here define coefficient of linear expansion. See here, this is the linear expansion definition. See, I am going to write here. Linear expansion is defined as the ratio of what is this? Change in length is defined as the change in length to the per unit length or original length, and the change in what? Degree Celsius, or the change in what? Temperature. This is the definition of what? A coefficient of linear expansion. Linear expansion. Right. After this one. I'm going to write here coefficient of linear expansion is defined as a increase in length, a increase in length per increase in length per increase in length per unit original length, unit original length, and the rise in temperature, the rise in temperature, the rise in what? Temperature, right? So this is the definition of what? Our coefficient of what? Linear expansion, coefficient of linear expansion, right? And another one thing I'm going to take, its SI unit, its SI unit. So once think what its SI unit, once think what its SI unit. See here the coefficient of linear expansion SI unit is this cell got cancelled. The temperature is only there, the temperature is only there. So what? Or per degree Celsius, per degree Celsius we can check, right? So I'm going to write here this is the SI unit, this is the SI unit, right? Got it? So here L plus delta L is equal to L plus delta L is equal to what? L dash. L plus delta L is equal to what? L dash. So I am going to take L dash minus L is equal to del L. L dash minus L is equal to what? Del L. Right. Now I am going to write L dash minus L is equal to what is our delta L? Can I write delta L? Alpha L del T, alpha L del T, right? So now here see L dash is equal to this minus L came here plus L, right? So L plus alpha L, alpha L. So once again L dash is equal to L 1 plus L 1 plus alpha del T. So here L dash is new length. L dash is new length. Right? ಗೊತ್ತಿರಲಿ ಸಿಂಪಲ್ ಏನು ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ L ಐತ್ರಿ ಆಲ್ರೆಡಿ. ಸೊ ಒರಿಜಿನಲ್ ಅಂತ ಎರಡು ಕೂಡಿಸಿ ಹೊಸ ಲೆಂತ್ ಆಗ್ತದೆ. ಮತ್ತೆ ಆ ಹೊಸ ಲೆಂತ್ ಅನ್ನ ಏನು ತಗೊಂಡ್ರಿ L dash ಅಂತ ತಗೊಂಡ್ರಿ. ಸಿಂಪಲ್ ರೀ. L ಡೆಲ್ಟಾ L ಐತ್ರಿ. L ಪ್ಲಸ್ ಡೆಲ್ಟಾ L ಕೂಡಿಸಿ ಇನ್ನೊಂದು L ಬರ್ತೈತ್ರಿ ಹೊಸ L. ಅದಕ್ಕೆ ಏನು ತಗೊಂಡ್ರಿ L dash ಅಂತ ತಗೊಂಡ್ರಿ. ರೈಟ್. ಸೊ ಈ ಈಕ್ವೇಷನ್ ಬರ್ಕೊಂಡು L dash ಈಗ ಬಿಡ್ತೀರಿ. ಈ L ಈ ಕಡೆ ತಗೋತೀರಿ ಮೈನಸ್ L ಆಗ್ತದೆ. ರೈಟ್. ಮೈನಸ್ L ಆಗಿದೆ. ಇದನ್ನ ಇಲ್ಲೇ ಬಿಡ್ತೀರಿ. ರೈಟ್. ಡೆಲ್ಟಾ L. ಸೊ ಒನ್ಸ್ ಅಗೇನ್ L dash minus L is equal to delta L value is alpha L into del T, right? So L dash is equal to once again minus L into plus L plus L plus alpha del T. So L to L common is common degree. ಅದು ಒರಿಜಿನಲ್ ತೋರ್ ಬರ್ತದೆ. So 1 plus alpha del T. ಟೆಂಪರೇಚರ್ ಆದಾಗ ಏನು ಚೇಂಜ್ ಆಗಿದೆ ಅನ್ನೋದಷ್ಟು ಬರ್ತದೆ. ಅವಾಗ ನನಗೆ ಏನು ಸಿಗ್ತದೆ? going to get the original the new length, right? So this is what linear expansion ಗೊತ್ತಿರಬೇಕು ಇದು, right?